This video is part 2 of lesson 3, and in lesson 3 we looked at integral exponents, and specifically with integral exponents what we are interested in is the negative exponent. And what happens when we have an answer or a variable with a negative exponent, what do we do? Just to do a super quick review of what we did in part 1, if you have a base to a negative exponent, in order to make that exponent positive, you are going to bring it down into the denominator. Okay. Likewise, if I had, let's say, 2 over b to the negative 3, if my negative exponent is already in the denominator, in order to make that positive, I would bring that back up to the numerator. So 2 times b to the 3. So just write that down at the top of the page um, so that you have just a quick review of what we did in part 1. All right, let's look at these examples here. So class example number 4, this is going to be a pretty complex example. And normally I say when we have a division, you're going to write this and then a division bar, right? But what I highly suggest doing is let's simplify this first. So let's take this and let's simplify this. So what we would get is, actually I'm going to write the first expression exactly as it is. 5x to the 3, y to the negative 8, z to the negative 2, divided by 15 divided by 1 is 15. Our x's, if I apply my exponent law, I would have 8 minus 5, which is x to the 3. My y's, you got to be really careful here. Some students want to cancel those y's, and you wouldn't cancel those y's. Because it's division, it's going to be y to the power of 3 minus negative 3. Two negatives give you a positive, and that would be y to the 6. Okay? For your z's, it's z to the negative 1 minus 2, which is z to the negative 3. So again, usually I say it's really good habit and practice to be able to do things in your head, but you want to always be right. So I say, always confirm negatives on your calculator just to make sure. Once we have it written like this, now I'm going to rewrite this with a division bar here. Okay? So what this becomes, that's my numerator. 5x to the 3, y to the negative 8, z to the negative 2. My denominator is this. So 15x to the 3, y to the 6, z to the negative 3. And now let's simplify. So 5 divided by 15, what that simplifies to be, 5 over 15 is 1/3. For my x's, x to the 3 divided by x to the 3, I could now cancel that because 3 minus 3 is 0. For my y's, so I always write my y's and my letters, my variables in my numerator, and then I'll get rid of the negative exponents at the very end. So negative 8 minus 6, negative 8 minus 6 is negative 14. And for my z's, I have negative 2 minus negative 3. So that's negative 2 plus 3, which is z to the 1. Okay, say to yourself, does anything move? And this moves. So in my denominator, I already have a 3 that has to stay. That y, I write it in my denominator and it becomes positive. Ask yourself, what would you do with that z? Z to the 1, does it stay up top or does it move down? So it's already positive. That gets to stay where it is. And I don't need to write that 1. And the other thing I'm not going to write is this 1 here. I mean, I could write that, but remember, if you have a coefficient of 1, we don't need to show that in our final answer. So my answer is z over 3y to the 14. Probably what I would recommend doing is, if this was a more difficult question for you, is take out a sheet of paper, rewrite this question, and see if you could do it without watching this video. Like, just see if you could do it for a second time. Number 5, explain why these two are not equivalent. So the equal sign with the um, bar slash through it is not equivalent. So again, just take this and let's solve for that. Let's simplify that. 2p to the negative 3. Okay, this is really 2 times p to the negative 3. So when I say I need that exponent to become positive, negative 3 to 3, what are you moving? The answer is only the p. So the 2 stays where it is, and the p moves to the denominator, and then it becomes positive. So what they've done, the mistake that was made, is they applied, like, they took everything down, but that negative 3, it only applies to the letter. So I hope you guys, or the variable, I hope everybody's able to see that. Okay, let's talk about fractions now. So the last thing that we have in the lesson is what happens when you get a fraction that's negative. And it's kind of interesting. So you know that if I gave you 2 down arrow, and that would be 1 over 2 to the 4, right? And then if I gave you, let's just say I gave you 1 over 3 to the negative 4, you would write that above, and you'd say that's 3 to the power of 4. What this section is on is what happens if I already give you a fraction. So they give you 2/3 to the negative 4. If you have a fraction, it's easy. And I want you to write this in your workbook. You take the reciprocal. You should add an AL at the end. RECRIPROCAL. You take the reciprocal. So what a reciprocal is, it's the following. If you have 2/3 and I say, what's the reciprocal of 2/3? You simply switch these two numbers and it's going to be 3 over 2. So if I give you 2 over 3 to the negative 4, and it's a fraction, we're going to do this for fractions. To go from a negative 4 to a positive 4, you take the reciprocal of the fraction, and that would be 3 over 2. From here, that 4 applies to the 3, and it applies to the 2. So 3 to the 4 over 2 to the 4. And then you would say 3 to the power of 4 is 81, and 2 to the power of 4 is 16. Okay? So again, let's do this one here. So 5 over 2 to the power of negative 3. So let's write that down. 5 over 2 to the power of negative 3. In order to go from a negative 3 to a positive 3, if it's a fraction, we only do this with fractions, you're going to take the reciprocal. So that's going to be 2 over 5. And as soon as you take the reciprocal, that negative 3 becomes positive 3. Now apply that negative 3 inside your bracket. So that's going to be 2 to the power of 3 over 5 to the power of 3. 2 to the power of 3 is 8. 5 to the power of 3 is 125. So again, in general, if you're given a fraction with a negative exponent, in order to get that exponent positive, you take a reciprocal of this. What I want to show you now, before we get to the homework, is I want you to, I'm going to give you something with letters. So let's say I gave you 2a over 3b to the negative 3. And I said, put that all to the power of negative 2. So the first thing you do is you say, okay, I have a negative 2 here. In order to go from a negative 2 to a positive 2, the only thing I have to do is take the reciprocal. So this 2a is now my denominator, and this is in my numerator. Now, sometimes students will say, wait a second, why did you bring the b up and you didn't make it positive? I'm not dealing with that at this stage here. All I'm dealing with is this exponent here. And the rule is for this outer exponent, when you have a fraction, to go from a negative 2 to a positive 2, you simply switch this exactly as it's written. Then from here, I could say, okay, let's apply that to everywhere. So 3 to the power of 2 is 9. Power to a power for my b's is going to be negative 6. 2 to the power of 2 is 4, a squared. From this point here, I could now say, okay, now I could deal with this negative 6. I need to bring that guy down. So this final answer would be 9 over 4a squared b to the 6. Okay, let's circle the homework. So 6 to 11, 12, and 13. I just want to make sure the other ones, 14, 15, 16, 17, we don't need to do. So let's have a look at those. So 6 to 11. So 6, 7, 8, 9, 10, and 11. And for all of those, I think I said A to D. Let me just double check. So 6 to 11, do A to E. Then let's look at 12 and 13. Okay, negative exponents. Perfect. So 12 and 13 are our negative exponents. So in order to go from a negative 3 to a 3, you're going to flip. Then from here, apply your 3. If I was to do set F up for you, so I'll set up F for you, the first thing I do is I want to go from a negative 2 to a 2. So in order to do that, I need to take the reciprocal. So that negative 8, x, negative 1, y, 5 goes up top. 12, x to the 3, y to the negative 1 goes below. And then from here, before you take care of the exponent, go to BEDMAS. So let's deal with our bracket first, right? Negative 8 divided by 12. So negative 8 divided by 12. If you need to reduce that, just remember you could check on your calculator. So negative 8 divided by 12. And then you're going to math one fraction it. That's negative 2/3. So they divided each of those by 4, right? Negative 2/3. My x's go together, and you're going to subtract those exponents. Negative 1 minus 3. That's going to be x to the negative 4. So you always begin by writing it on top. My y's are going to be 5 minus negative 1, which is y to the 6th. And then that's to the power of 2. From here, you could apply that 2 at this stage, or you could bring your x down. You could do either or. You'll get the right answer. So if I was to apply the 2, right? So apply the 2 everywhere. Um, negative 2 to the power of 2 is 4. X to the negative 8, y to the 12, 3 to the power of 2, 3 squared is 9. Then get rid of this. So 4, y to the 12, all over 9 x to the 8. And that would be your final answer.